For physics class, we were asked to make a video explaining a law in the physics field. My team chose one law of motion stated by Newton. The law in which we are going to be focusing is Newton's second law of motion, which describes how much an object will accelerate for a given net force. A force is a push or pull, meaning that the net force is just the sum of all the forces that act on an object. Newton's second law states that the acceleration of an object is dependent on the net force acting on the object and the object's mass. The acceleration of an object depends directly upon the net force acting upon the object. On the other hand, it depends inversely upon the mass of said object, meaning that as the mass of the object increases, then the acceleration of it decreases. So, Newton's second law of motion can be stated as the following. The acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force, in the same direction as the net force and inversely proportional to the mass of the object.
The net force is equated to the product of the mass times acceleration. The acceleration is directly proportional to the net force. The net force equals mass times acceleration. The unit that we use to measure force is newtons, which equals to a unit of mass times a unit of acceleration. The equation used for the second law of Newton is F, which is force, equals to mass times acceleration, and they are represented as m times a. Now, you can isolate to get either mass or acceleration. Now, we will have some examples for the use of this formula. So, the first example that we'll use is determine the acceleration that results when a 12 net force is applied to a 3 kilogram object. The first thing we need to do is to isolate the formula force equals mass times acceleration to leave alone the A, which is the acceleration. By isolating the formula, we have that acceleration is force divided into the mass. Now we can substitute the data that the problem gave to us, which means we have acceleration equals 12 newtons, which is the force, divided by 3 kilograms, which is the mass. Now, the only thing you gotta do is to do the operations. So we have that acceleration is equal to 4 meters per second squared. For the second example, we will be asking to find mass. So the first thing you need to do is to isolate the formula F equals to m times A. Isolating for m, by isolating the formula, we have that mass equals to force divided by acceleration. So the second example says, a net force of 15 newtons is exerted on an encyclopedia to cause it to accelerate at a rate of 5 meters per second squared. Determine the mass of the encyclopedia. So you need to remember what you already isolate, which is mass equals force divided by acceleration. Gather the information you have. You have that a net force of 15 newtons accelerates at 5 meters per second squared. You gotta substitute this data in the formula. So you have mass equals to 15 newtons divided by 5 meters per second squared. So mass equals to 3 kilograms, which is your answer. And the last example is to find the force. The problem says, determine the force that result when a 10 kilogram object is accelerating at 5 meters per second square. All you have to do is to substitute the data in the formula, which is force equals mass times acceleration. So we have that mass equals to 10 kilograms and acceleration, which is 5 meters per second square. By putting this in the formula is force equals to 10 kilograms times 5 meters per second square. You make the operations and the result is force equals to 15 newtons, which is the unit that we use to measure force.
Now for the experiment, we're gonna need a toy car, a straw, a rubber band, a tape, and a balloon. We're gonna put the straw inside the balloon, and then we're gonna tie them with the rubber band, and finally we're gonna just tape it to the car, to the top of the car, so we can see what happens next when we inflate the balloon through the straw. This is gonna make an action, and the car will move due to the air and the force of light.